Every line of code Claude writes for you contains an invisible watermark. Your editor cannot see it, your terminal will not display it, and your linter will never flag it. But open a hex editor, look at the raw bytes, and you will find something buried between every word. Zero-width Unicode characters, carrying a hidden payload that traces back to your exact session. This is not speculation, it is confirmed directly in the source code. Earlier this year, Anthropic accidentally published a source map file to the NPM registry. Developers reverse-engineered it and found an entire Steganography module hiding in plain sight. Today, we will break down exactly how this watermark works at the byte level, why Anthropic built it, what data it encodes, and what it means for you. This is the biggest AI transparency story of the year, and almost nobody covered it properly. Let us start with how this was discovered, because the backstory matters. In March of 2026, Anthropic shipped a new version of Claude Code to the NPM registry. But they made a critical mistake. The build pipeline included the original source map file. A source map maps minified production code back to its original readable source. Within hours, developers on Hacker News had decompiled the entire Claude Code client. They found fake tool definitions, frustration detection rejects, and an undercover mode. But the most alarming discovery was a module called steg.ts, short for Steganography. That single file contained all the logic needed to embed invisible tracking data into every response. The post documenting this hit 2,400 points on Hacker News, the highest-scoring AI story that week. Clearly, the developer community felt strongly that this needed to be understood. Before we dive into the code, let us clarify what Steganography actually is. Steganography is hiding a message inside another message so no one knows it exists. It is different from encryption, where everyone can see that a secret exists but cannot read it. With Steganography, the goal is that no one even suspects a hidden message is present at all. Historically, spies used invisible ink, microdots, and even subtle changes in letter spacing. In the digital age, Steganography hides data in image pixels, audio samples, or, in this case, Unicode text. Unicode has over 144,000 characters, and some of them have zero visual width. These zero-width characters are legitimate parts of the Unicode standard, used for things like text shaping. But they can also be repurposed as a covert data channel, and that is exactly what Claude Code does. So how does Claude Code actually hide a fingerprint inside plain text? It uses two specific Unicode characters, the zero-width joiner and the zero-width non-joiner. The zero-width joiner represents a binary 1, and the zero-width non-joiner represents a binary 0. Each pair of these invisible characters encodes a single bit of information. String 8 of these bits together and you get 1 byte, 1 character of the session identifier. The module then inserts these invisible sequences into the spaces between words in every response. A typical Claude Code response might carry anywhere from 50 to 100 bytes of hidden metadata. That is enough to encode a full session ID, a timestamp, and potentially a user-level identifier. Your code editor will never show them. They render as zero-width, meaning they occupy no visible space. Only a hex editor, or a specialized Unicode inspector, can reveal the hidden payload sitting in your code. Now, here is where the story takes a sharp turn that most coverage completely missed. Your first instinct is probably that Anthropic is tracking your prompts for surveillance. That is the narrative that spread across social media, and it is almost entirely wrong. The Steganography module is not designed to spy on users. It is designed to protect against prompt injection. Specifically, it exists to prevent a dangerous class of attack in multi-agent AI systems. When an AI agent reads code generated by another agent, it can be tricked into following hidden instructions. This is called indirect prompt injection, and it is one of the hardest unsolved problems in AI security. The watermark gives Claude Code a way to recognize its own output and treat it with appropriate caution. Think of it like a return address on an envelope. It tells you where the content came from. That context is critical for deciding how much to trust the instructions embedded in that text. Let us walk through how this self-recognition works in a real coding session. You open Claude Code and ask it to refactor a function, a perfectly normal request. Claude generates a response, and the Steg module silently injects the session watermark between every word. You paste that refactored code into your project and commit it to your repository. Later, another AI agent, or even Claude Code itself, reads that file as part of a new task. The Steg module detects the watermark and immediately knows this code was generated by an AI, not written by a human. This matters because AI-generated text could contain adversarial instructions from a third party. By recognizing its own output, Claude applies a stricter parsing mode and refuses suspicious directives. Without this mechanism, a recursive agent loop could be tricked into executing arbitrary commands. The watermark essentially breaks the attack chain by making AI-generated content identifiable at the protocol level. Even with this legitimate security purpose, there are real privacy concerns worth addressing. The watermark encodes a session identifier, meaning Anthropic could theoretically trace output to a session. If that session links to your API key or account, the attribution chain becomes personally identifiable. This is especially relevant for developers working on proprietary code that they do not want externally attributable. The community has also raised questions about consent. Users were never explicitly told about this feature. Transparency in AI tooling is not optional. Developers deserve to know what metadata is attached to their output. On the other hand, the watermark does not phone home. It is embedded locally and only meaningful if extracted. There is no evidence of an active data collection pipeline that harvests these watermarks from user code. The debate comes down to intent versus capability. The tooling exists, even if it is not currently being abused. If you want to check whether your code contains these invisible characters, it is surprisingly simple. Open any file generated by Claude Code in a hex editor or run a simple grep for zero-width Unicode code points. The two code points you are looking for are U+200C for the zero-width non-joiner and U+200D for the joiner. If you find clusters of these characters at word boundaries, that is the steganographic watermark. Stripping them is equally straightforward. A single sed command or a find and replace can remove every instance. Several open-source tools have already been published specifically to detect and remove Claude Code watermarks. However, stripping the watermark also removes the prompt injection protection that it provides. So the decision to remove it is a genuine trade-off between privacy preferences and security benefits. For most individual developers, the watermark is harmless, but for enterprises handling sensitive code, it warrants a policy decision. This story is part of a larger trend reshaping how we think about code authorship. As AI-generated code becomes the majority of new code written, attribution becomes a fundamental infrastructure problem. Who wrote this function? A human, Claude, Copilot, or a chain of 3 agents collaborating autonomously? Steganographic watermarks are one answer, but they are fragile. Any text transformation can destroy them. Cryptographic signing is another approach, but it adds latency and requires key management. Some researchers explore model-level watermarking, where token sampling is biased to produce a statistical signature. The European Union's AI Act already requires AI-generated content to be identifiable, making this a regulatory issue too. Whatever solution wins, the era of unmarked AI-generated code is almost certainly coming to an end. Claude Code's Steganography module is an early, imperfect attempt at solving a problem that every AI company will face. Here is the actionable takeaway, and it is more nuanced than just fear or dismissal. First, audit your AI-generated code for zero-width characters if you handle sensitive code. Second, understand that the watermark serves a real security function. It is not surveillance for the sake of surveillance. Third, advocate for transparency. AI tools should disclose metadata practices in their terms of service. Fourth, if you strip the watermark, do it knowingly and accept that you are removing a layer of protection. The broader lesson is that AI tools are no longer simple text generators. They are systems with trust opinions. Every response Claude sends makes a statement about provenance, authorship, and chain of custody. We need to understand these hidden mechanisms, not because they are malicious, but because they matter. Your AI-generated code carries more information than you think, and now you know exactly what it is.